Find the following antiderivatives. In the left example, you'll see that you are trying to find an antiderivative of the quantity a squared minus 2 times the quantity a plus 7 with respect to a. Now, in its current form, we cannot find the antiderivative of this expression. Since we only understand power rule at this point in time, we need to be able to use a power rule here. There's no trigonometric expressions here, so we need to use the power rule. And in order to get something that will give us power rule, we need to distribute these two expressions to one another. And when you do that, you'll see that you get the antiderivative of a cubed plus 7a squared minus 2a minus 14 with respect to a. And from here we can use the power rule to find the antiderivative. So I'm going to just look at each term individually. This first term, a to the third power. A to the third power, when you use the power rule, tells you to add 1 to the exponent, so a to the fourth, and you multiply that times the reciprocal of the new exponent. Plus, I'm going to do 7a squared, so I'm going to have 7a, add 1 to the exponent, so 2 plus 1 is 3. Multiply this term by the reciprocal of the new exponent. This next term, minus 2a, so minus 2a, add 1 to the exponent, multiply by the reciprocal of the exponent. And the last term over here, minus 14, will turn into minus 14a. There's an a to the 0 power hidden in here. So when you add 1 to the exponent, you get a to the first power. And then lastly, we cannot forget plus c. So now that we have an expression here, we should probably just go ahead and simplify anything that we can. So I'm going to rewrite this as 1/4 a to the fourth power plus 7/3 a cubed minus a squared minus 14a plus c. And here's an answer for the antiderivative of the first example. In this right example, we cannot use a power rule yet because we don't have separated terms like we did over here in this example. But we can get separated terms if we take the denominator and divide each term of the numerator by it separately, so that it'll look something like this. The antiderivative of x cubed over x cubed minus 7x over x cubed plus 2 over x cubed, all with respect to x. Then what we can do is simplify each of these terms into something like this. So the integral, or the antiderivative of 1 minus 7 over x squared plus 2 over x cubed dx. Then what we need to do is we need to make sure that all of these x's in the denominator get bumped up to the numerator. So the last rewrite that we will need will be the integral of 1 minus 7x to the negative 2 power plus 2x to the negative 3 power dx. Now we can go ahead and find the antiderivative for each term. So when we do this, we're taking the antiderivative with respect to x. So when I find the antiderivative of 1, it will end up having a variable x. The next term, minus 7x to the negative 2 power, this will be minus 7x. If you add 1 to negative 2, it becomes negative 1. Multiply by the reciprocal of the new power. To that, I'm going to add this one, 2 times x, add 1 to negative 3, you get negative 2, to the 1 over negative 2 power. And then, of course, at the very end, plus c. Finally, all we need to do is simplify our numbers. So x subtracting a negative 1 is the same thing as adding 7x to the negative 1 power. 2 and negative 2 will reduce so that this becomes minus x to the negative 2 power. And then lastly, since there are negative exponents here, we need to get rid of those as well. So this will leave us with x plus 7 over x minus 1 over x squared plus c. Please do not forget your plus c's at the end of these antiderivatives. Here is your answer for this antiderivative.